Start to our morning this morning with Dana Lewin from the Computer History Museum and Dr. Ashwin Ram talking about AI and hardware and the implications of that. One of the things that Ashwin actually talked about that I think is really interesting in light of our next panel is how we're looking at technology to improve the human condition and human life. And I think that it's really interesting that we're considering how our technology can actually improve humanity when we consider both AI as well as robotics. It's a really controversial subject for a lot of people and a lot of people worldwide. And you know, I'm going to turn it over to somebody who is not afraid of the controversy, who actually really even tries to dig right in, an expert in both robotics and one of the co-founders of the Silicon Valley Robotics Group, and well as an expert in human presence robots. Erin Rapacki has been with Hardwarecon for a number of years. I've known her since I think 2011 or 2012, and has actually even brought the Beam robot and these telepresence robots here. She speaks all over the world on robotics and has pulled together a distinguished panel of experts that are going to dig into the controversies and the future of our friendly robot society. So please join me in welcoming Erin and our robotics experts.
Thank you, Beth. Is this on? Are we good? Okay. Good morning, everyone. I'd like to introduce the panel this morning. Paul Birkmeyer from Dishcraft Robotics, Jill Ogle, and Phil Herget from Dusty Robotics. I don't know if you want to go through and maybe expand a little more about what you do and what interests you and how you involve robots in your everyday.
Sure. I come from definitely an R&D background. Did a lot of big robots at a place, SRI International, where we did a lot of stuff for the military, commercial enterprises. A lot of those wouldn't really turn into products, and so ended up finding an opportunity with Dishcraft Robotics to do robots for commercial kitchens. We're experiencing a lot of the same problems that you guys are at Dusty, and so trying to find a place where robots can augment existing businesses and fill holes and try to make the experience better for their staff is what we're up to. So.
My name is Jillian Noble. I am the founder and CEO of Let's Robot. My background's a bit different than most of the people in the robotics space. I actually come from video games. I was a game designer at Disney Interactive previously, and I worked at a bunch of other game companies before that. And so what got me into robotics was just sort of the convergence of robotics and interactive media, and how to use robotics to help people gain access to experiences and like new forms of entertainment that they wouldn't be able to access otherwise. And so that's what I explore with my company, which is what is, I would describe it as a live streaming site for robots, or Twitch for robots, where anyone can go online, they can add a robot to our site, and then anyone in the world can go on and control it. And they do this like a shared collective voting system. And this allows you to, instead of just watching content, you're actually doing stuff and participating. And that's kind of where my area of interest has been in robotics. Yeah.
Awesome.
I'm Phil Herget. I have a hardware background. I was, from my previous company was Savioke. We made hotel delivery robots. And what really excites me about robotics is an area where you can interact with the world. So you can build something that doesn't just sit in a computer and have just an interface, but something that can actually have an impact and change the world. And our Savioke robots, the relay robot, was a delivery robot. We were able to make deliveries to guests in hotel rooms, and it was an awesome experience to watch people interact with the robot and it actually be doing useful work. And just recently, I founded this new startup, which is Dusty Robotics, and we are in the space of construction robotics. The application is printing in the construction site. So our robot is taking the blueprints that everyone on the site has to use and taking that information and printing it onto the ground so people can build off of it, and all the information they have is right where they need it.
Very cool. Now, I know here at Hardwarecon, we like talking about hardware, and I'll get into the technology a little bit. So I like to reminisce a little. I remember back in 2010 when many of us in the robotics community and startup community were excited about the rollout of 4G data and the Microsoft Connect. What advances in robotics have you witnessed happening in the past decade? And please paint a picture of what it was like 10 years ago and what you see happening now.
Who's first?
Anyone?
I can start.
Yeah.
So I think mentioning the Kinect is really interesting. So the Kinect had inside it a sensor from PrimeSense. PrimeSense has this depth camera, basically, and back when that came out, it was the only such product on the market. When we founded Saviok, we were building a robot that's going to interact with people in hotels. And it was critical for us to have this depth information to be able to sense what's going on in the world. And we founded the company probably a month or two before Apple bought PrimeSense and took the sensor off the market. So we ran into this head-on into this problem that the main sensor we needed for our product was no longer available. And we actually solved the problem in the short run by we found another company that was selling a product that had a PrimeSense in it. And we decided, okay, let's buy a couple of these products and then let's open them up and harvest out the PrimeSense and use it for our early prototyping. And we actually were worried that if we bought a bunch of these, the company would figure it out and not sell it to us. And so all the founders actually went home and everyone bought one or two on their personal account and shipped it to their home address. And actually we later talked to the CEO of that company, and they had figured it out because they saw these orders for 2 cameras coming in from a couple different people, and they figured out we were all in the same company. But they sold it to us anyway. But we ran, that was 2013, and we ran into this problem of the sensors we needed were not out there in the world. And then later, the inventory from PrimeSense went onto the market, and there were kind of hundreds of these sensors suddenly available. And we had a big meeting and said, okay, there's no other sensor we can use out there. We have to buy some of these. The big question is, how many do we buy? Because we had to kind of predict, well, how many robots are we going to produce in the X amount of time? And when do we think somebody will have a new sensor on the market? So we had to estimate all these different things and use our precious resources to buy up some sensors in advance so they're available. So, that was 2013, and a lot of the sensors and technology you needed to build robots were not on the market. And now today, things are looking totally different. There's a lot of different LiDARs, there's a lot of different sensors. When we started Dusty, we're using an off-the-shelf robot base to make our prototypes, which were not available at the time when we started Saviok. So things have changed quite a bit.
So to add to that, I'd say the biggest thing for me is, so 10 years ago, I wasn't in robotics at all. I was making games. And I only got into robotics about 4 or 5 years ago. And that's around the time Raspberry Pi started becoming a thing, Arduino started becoming a thing. And I think the thing that's really changed, at least the thing that brought me into robotics, was the accessibility of it. And just the support and infrastructure around all of the, the different pieces of hardware and everything you ever need to learn, in order to do stuff. I went from not knowing anything about hardware or robotics, and I'm not super technical, to being able to build basically a full homemade telepresence robot in a month. It's amazing that I was just able to prototype that and put that together. And that wouldn't have been possible without things like Raspberry Pi or Arduino or parallax activity bots and all that kind of stuff. Conversely, too, on the just on the web, there's just so many tutorials, so many things to teach you, how to use a Raspberry Pi, how to make these interfaces, what does all of this stuff mean? And I'd say, and as I've developed my platform, that's become pretty obvious too. It's nobody would be able to participate in our site if this stuff wasn't so accessible. We've had over 1,000 homemade and homebrew robots added to our site, which is pretty amazing. And 10 years ago, that would have been impossible. And I don't even think it would have been really possible to buy cheap off-the-shelf stuff that you could do like real-time video streaming with either, without breaking the bank. So that's been a big change for me.
Very cool.
I mean, I think a lot has happened, right? So in the last 10 years, people started to believe in self-driving cars, right? And I think that's pushed that market for computing that can fit in a car, that can handle all of that crazy data, and it's forcing sensor markets, as you know, to make very robust, very capable sensors for that market, which has a really nice trickle-down effect to everyone else. I haven't seen 4G actually pan out super well because when you're making these robots especially for industrial applications, you need reliable connections, and I think a lot of the algorithms we're using now are using a ton of data. And so that's not possible reliably on 4G, and so you see a lot of Wi-Fi products, but you're also seeing a lot of edge computing stuff. So if you can't rely on having good connectivity, you have to do the computing locally. So recently there's still been a lot of new products pushed out by NVIDIA. Google's pushed out their own Coral sort of edge computing stuff. So I think that's going to enable even a lot more as people develop custom silicon for hardware at the edge of the network. I think that's going to enable a lot of opportunity.
Yeah, I think the one thing I see self-driving cars as somewhat being this generation's Apollo program, where we might not get self-driving cars, or we're not really sure when we're going to get that, but it is something that pushes the technology forward into realms that we haven't had to explore yet. And what's funny about 4G is now that everyone's on it, the service has actually degraded. So your 4G now is worse than it was 5 years ago.
Yeah.
And robots that need to remain cloud connected, I can talk offline about that, but a robot cannot really be cloud connected for real-time data processing. Right. It's just not an option right now, and we can go offline. But yeah, there's still, so a lot of progress has been made in the past 10 years, but there's still progress to be made on components.
Yeah.
I'd like to switch over to somewhat what is different in the market. Who wants to buy robots? What are the world has actually changed a bit, I feel, in the past 10 years. What are the macroeconomic differences between 2010 and now? Like globalization, labor shifts, skills gap, urbanization, aging, like demographics for workforce, and even consumer behavior. What do you think has shifted, and why do you think there's a demand for robotic products?
I think my company basically exists because the hospitality industry cannot find people to do the work that they need to do to stay in business. And I think that's for a few different reasons. One is a lot of the work is very hard, and the nature of work that people want to take on is very different these days. I think the expectations of what a job is very different. Wages are going up. The workforce, especially in today's economy, especially local workforces, are really hard to find. Let's see, in hospitality, people are eating out more, so this is specific to my industry, but a lot of people, I think a third of the population, one or more of their meals a day is not prepared by them. And so expectations for eating out, having higher quality products, so a lot of these consumer electronic devices have to be made by robots. Even if you're not buying the robot, you are enabling people to have more robots in their assembly process. Like, you can't make lithium-ion batteries safely with people, and they're in everything. And so those are done by robots. So that's driving a big part of the robot economy as well.
I would say, for me, the most kind of important thing that I've observed, at least as far as market macro behavior and stuff like that, is when you're thinking about a robotics consumer-based product, I think that there's always a market for the next thing, and what we're basically doing is just waiting for the technology to unlock it, right? So, in order to be, to run around a hotel and serve guests, right, the technology has to be there. In order to help people in a store, the technology has to be there. So those potential markets are huge. I think that there's been, the rise of AI deep learning has really changed stuff. Cloud-based computing has really changed stuff, like as far as the markets go. And I'd say that there's just a general mindfulness now of what automation is going to mean for us in the future, because we're not looking only at, replacing just, this factory over here or this job over here. We're thinking about replacing entire industries now, like the automotive industry, with automation, and that's going to be a huge upheaval. And I'm glad to see at least there's some social awareness of that and what the impact of that would be. And I would say that that's probably the big, going to be a big, thing pretty soon. But yeah, as far as everything else goes, like I think it's just basically it's when the technology is there, the market's there. It's just, is it more efficient? Is it cheaper? Is it better than it was before? And I think it'll keep going that way.
So I was previously in the hotel industry with this hotel delivery robot, and the construction industry is really new to me. I witnessed a remodel of a house and saw how primitive everything was. I mean, there was no technology really used at all. Blueprints were printed on paper. They did some designs on, in a computer, but beyond that, everything on the site, all the construction activities, everything is just manual labor, paper. Notes are scribbled on 2x4s while they're building things. So we headed into this direction of construction, saying, "Wow, there's probably a lot of opportunity here." And we spent a long time talking to a lot of people in the construction industry, and we came to the conclusion that the industry, probably in the last 10 years, has really changed, and that people are now ready and hungry for technology, which they weren't 10 years ago. So, and you find that if you talk to construction companies, you find that they generally have an innovation team. The innovation team is seeking out startups and seeking out technology that's out there. They're worrying about how can we digitize designs, how can we get the designs onto the construction site and get information out using, get tablets out into the field, manage things through computers, instead of doing it all on paper the way it used to be done. So it was really surprising. And we studied the construction industry and also learned that there's a labor shortage. Basically, if you look at a plot of the number of unfilled positions in construction sites over the last 10 years, it's been steadily increasing. So people are looking for ways in which they can get this labor done, basically. And I think 10 years ago, that industry looked completely different. And I think that applies probably to a lot of different industries, I guess, warehouses, all kinds of different industrial industries. And I think just society in general is at a point where we're ready for robots, and we want them to appear.
Go for it, yeah.
I think people's expectations around quality also has really impacted things. So let me think of an example. So like surgical robotics. Surgical robotics are not replacing surgeons, but they are basically elevating the baseline so that the average surgery that's performed is as good as if it were performed by the best surgeon in the world, right? And so I think that's an opportunity for robotics, and that's what we're trying to do too, is like elevate the quality of the work, both in terms of the environment for the people, but also the output. And I think that goes along with people's expectations for quality. Like welding in cars now is all automated because the expectations on craftsmanship is so high. And I think, so I think that's also another part of why robots are becoming more common, at least in industrial applications.
Yeah, the importance of quality and also the importance of safety. Regarding construction, I spent some time looking at sandblasting. Sandblasting is you spray sand at a coating, like a bridge, if you need to remove the coating and replace the coating. And actually, I crawled up under a bridge with all the sandblasting gear on over in Massachusetts and sandblasted a bridge, and that was so dangerous but so fun. And to see if a robot could do it. So I was figuring out if we could handle the back thrust. OSHA was instigating a new rule that the silica in sandblasting is carcinogenic. And so where one person could sandblast for 8 hours, OSHA was now regulating that that job be split up among 3 people, which makes it an easier thing, but it hurts staffing, it hurts your return. And there's all these interesting things, learning about refurbishing highway bridges. The government has not raised the limits on which you could bid a project since 1992, but all of the vendors' costs are going up. So if you were sandblasting bridges in 1992, you are not getting paid more today. You're just not making any money to do this work. So there's this issue, this tension between costs not rising or you can't bid higher and getting the work done. And people are hoping robotics and automation kind of relieve that tension, because you're not going to stay in business sandblasting highway bridges if you can't make any money. But right now there's a struggle. I don't know, and also, I also learning that family size is different. So whereas like we had more immigrant labor pools or people willing to, who came from families with 6 or 7 kids, nowadays family sizes have 2 kids. And there's just kind of fewer people to go into the workforce, and rightfully so, they are choosing to pursue better jobs for themselves and more opportunities. You guys seen anything similar to that?
Well, in the construction industry, we found that safety is really important. I mean, construction companies have a very strong focus on safety, and the level of safety keeps increasing. You can see actually nowadays, if you go around and look at a building that's being constructed, the top floor will have netting around the outside to catch any, if somebody were to fall off, but more importantly, if somebody were to drop something and it was to hit somebody that's walking around on the ground, they put netting on the floor that they're building. So they keep increasing the level of safety on the job site, and safety costs them a lot of money when there is an accident, and they're very focused on that. And robotics really has an opportunity to help with safety, because there are a lot of tasks that are very dangerous, and when people perform those tasks, they need a lot of training, they need a lot of expertise. They tend to be very expensive people, and the insurance for those operations also costs a lot of money. And if you bring in a robot, you can do that much more cheaply and have a safer job site.
Jill, I think you had some comments on like telecommuting or remote work.
Oh, yeah. So, like, I believe that, like, telepresence and telerobotics is basically the ultimate collaboration tool. And I see that as devices sort of get, smarter, they get more capabilities, and we have a lot more reasons to have robots with very specific, narrow capabilities sitting around. I think that we'll see, eventually we'll hit a point where, our location will be not that important when it comes to, the physical work, like it is right now with like technology work. Like if I'm doing, software work and I can work at home today, it's not a big deal. I think robotics is going to allow that in the future with telepresence and, having like robots on the job site and stuff like that. So you could be a construction worker, you could be sitting at home and, working through a construction robot. Because the way that it's probably going to, or at least the way that I see it, like kind of panning out, is you're gonna have this starting point where you have a robot and you have all this capability and capacity, except that, right now they're just not quite smart enough to say, print a building and it'll just build the whole building, right? That would be nice. But, for now, you're just going to get robots that, can do a lot of stuff at a low level, at a baseline. And then you're going to have human people who are either managing like one robot or a group of robots, like you were talking about with the surgeon earlier, where you want to raise like the baseline performance level, right? So we'll have humans sort of augmenting the robots for a very long time. And and that's also going to be very disruptive to you know, the economy as well, and also disruptive a bit to our lives. You know, when you no longer have to show up for your physical labor job, like physically, you know, yeah.
Some opportunities, yeah.
Yes.
You don't have to injure yourself to go to work.
Exactly.
Nice. Actually, speaking about injuries and safety, right now we see a barrier between robots and people. Like, for example, robots inside a factory, there's a safety fence. A mobile robot in a hotel might follow the same rules as an automated guided vehicle in a factory. Or we might see a restaurant service robot making food behind glass. In a future of coexistence between robotics and people were to exist, what technologies do we need to develop, and how does advanced hardware play a role in that?
I don't know how to solve it yet, and I think there are companies that are working on it, but I think probably one of the biggest barriers is having something that's deterministic in a robot and something that's predictable. And so if you look at a lot of the safety regulations, so we're working very hard we think our robot will make our environment safer as well, but we also need the robot itself to be safe to be around. And we're working with regulatory bodies, and they just were like, no, we need to know exactly how risky this is, and that if I take this action, it will not do anything. Like, it won't hurt anyone. It won't be possible for it to happen. There's like no physical way for that to happen. And I think by having robots that are coexisting with people, you have to, at least to meet the current standards, you have to know how it's going to behave. And I think a lot of the algorithms we have now that are more data-driven are not deterministic in the same way. And so I don't know how you solve it. I do know that there are companies out there that are using cameras to try to track a person, infer their intention, predict what they're going to do, and have the robot respond to that. That's a tough challenge. So right now the solution is either like box it off or to make it go slow so you can't hurt it.
So the variation of the task makes it difficult to safety regulate.
Yeah, exactly. So that's why I think you see industrial applications where you can constrain the environment. I think home robots, unless they're very safe like a Roomba or a Nito vacuum, are like, that's kind of the limit. I don't know, it's a tough problem. Anyone else have a solution?
Sure. Well, we had, you know, Savioke robot is operating in hotels, and there's kids, there's elderly people, there's animals, dogs sometimes.
Swimming pools?
And yeah, there's swimming pools. We spent an awful lot of time on safety. I think the technology is there to make things safe. I mean, it's just spending the engineering time and thinking through all the cases and designing something, you know, putting the effort in to make it safe. I think the technology actually exists out there. One of the things that we found that was lacking a little was the standards. How do you certify something to be safe? If you're going to put it into a warehouse, if you're going to put it into a factory, there are lots of standards to go by. If you're going to put it into a hotel, you know, it was new territory, basically. We had to figure out how we make this safe, how do we feel comfortable about it, and which standards do we feel we need to adhere to make this safe. I think on the other front of your question, which is what will allow robots to exist in our society, you know, we had a lot of issues with connecting robots to elevators. I mean, if a robot's going to move through a human space, it has to be able to use all of the things that humans would use. It has to use elevators, has to be able to open doors. It would be great if it could go upstairs too. And all of those things are challenging problems. And it also, to be able to use some of that infrastructure and to be able to communicate with the infrastructure in a building, it needs to have a great Wi-Fi connection, which was also a really big challenge. Wi-Fi, you know, in a hotel, it works great because it's designed to work in your room, but it was not designed to work in the elevator, in the hallways, everywhere else. So we did have a lot of issues with that. So I think technology-wise, if we improve our Wi-Fi networks, if we improve the connectivity of the infrastructure so a robot can tap into it, that would go a very long way to making robots enabled to move around in human spaces.
So I think that there's sort of this shift from controlled environments to being out in the open world with people. And so everything that the robot needs to know is sort of has to exist on board the robot, especially since there isn't a whole, like you said, like 4G is like not that great, right? I think kind of important things are, you know, the robot's gotta kind of, if you're gonna have them existing with people in people's spaces, they've gotta be friendly. A little friendly looking, a little nice looking, a little bit, you know, what you'd expect a robot to look like or act like. And predictable. And I think that's kind of the biggest thing is like, I want to look at this robot, I want to see what it's doing, I want to be able to make an accurate prediction, you know, as to what it's doing while it's navigating a public space. And so that way, like, you know, I'm able to, as a human, navigate around it safely, and we're not going to do the awkward, you know, penguin walk at each other or something like on the sidewalk. And I think that's quite a challenge, right? To make your robot just able to do all of that social interaction necessary when entering a public space and navigating a crowd of people or a crowded sidewalk or a road and merging onto traffic and those things.
Yeah, I mean, I think if you have enough data and you can say, well, you know, 999,000 times out of 100,000 times. Wait, no, 1,000,000 times. I can't remember. Anyway.
Six Sigma?
Yeah, exactly. Thank you. That's a better way to say it.
99.999%
And you can,
uptime.
that's one of the things robots are really good at is generating and collecting data. And so I think this is going to probably happen with self-driving cars, or at least augmented driving cars, is they'll have data that they can rely on, and they can say, well, we put in 1 billion miles, we saw this many accidents, therefore it's safer. But for like small batch robots, I think that's going to be harder to do.
Yeah.
Oh, you just can't get that kind of statistic from a small deployment.
Right.
So it's a chicken and egg problem that you need all the robots to be out there if they're safe enough.
Yeah.
Great. Okay. On that note, something I love to do for the hardware audience is share war stories. There's some kind of camaraderie or mutual, you know, we've all been there. So if we can go down the line, I'll share a war story. War stories from, you know, I didn't know that would catch on fire, or that caught me off guard there. One of the war stories I like to share with startups is the relationship between what your engineering and design team is responsible for versus what your contract manufacturer's engineering design team is responsible. Like what is that line of design for manufacturing? And so at one of my previous startups, we built 25 prototypes. None of them were the same. They didn't exactly work. They failed in all of these different ways. And we expected our contract manufacturer to fix the problem for us. No, so what I espouse in terms of war stories is your internal team is still responsible for having a number of repeatable designs meeting a test metric equally before your manufacturer can really help you with DFM, because they're not your engineering team. They're not building the IP for you. They're just repeating the same design that you're putting out there. So it sounds like 1 minute each. We just got the 3-minute sign.
Cool, perfect.
Advice or war stories for people out there?
Always test your product in the environment that you expect to use it in before you deploy. So at SRI, we had worked on a bunch of really cool projects, one of which was augmenting soldiers, their locomotion, by putting motors on the body, actuating for them. So in theory, they use less energy, they get less tired, they're more alert, they have fewer injuries. And we built this suit. It's really awesome. It's the core tech for Seismic, which is a startup now. We built it in Menlo Park. We tested it on a treadmill. I was a test subject for a long time because I was writing the controls and doing all the electrical stuff. And did a final pass on the hardware. We went out to Virginia in the winter to do field tests on soldiers, and it was really awesome. It did really well in the field. We had great results. And then on the second day, we found that a lot of the hardware had failed.
Ooh.
And so I couldn't figure out why, and I would watch every step of the process, and I noticed that when people were taking off the hardware from the soldiers, I would hear those little electrostatic shocks, which is common in dry winter places, but not so much in Menlo Park, never had ESD problems in Menlo Park. And what was happening is it would shock the cable that would go all the way up to my motor controller and blow out the encoder. And so I was just like burning through electronics until we figured that problem out. In the field is not the fun way to solve that.
I think I have to move.
Yeah.
Oh, sure, yeah.
Yeah.
So, my business is you take robots and you hook them up online for strangers on the internet to control, and they have full control of the robot. So, this is a recipe for chaos. And people have done all kinds of crazy stuff. They've added Roombas, they've added BattleBots. Somebody hooked up a lawnmower that got posted on Reddit. We had 10,000 people trying to drive a lawnmower in Nebraska, and then they tried to mow the neighbor's lawn. And so it's like all of this crazy stuff. I have like so many stories, but even out of all that chaos, there's like still really awesome stuff that like touches me personally. So one of the projects that I had when I was just getting going was I made a robot that played Pokemon Go. And this was even before I started trying to do the platform by itself. So I had a robot. It was like a Mars rover. It actually physically held a phone. And this was when Pokemon Go was like still new and everybody was crazed. And it could use a stylus and actually like catch Pokemon and like stuff like that. And so I took this robot out and I took it to parks and I took it in public places and I let everyone just log in and go play Pokemon Go like wherever they wanted to go. A few weeks later, I got an email from a user that was, sorry.
Yeah.
Yeah, well, basically they were unable to go outside and play this game because they were disabled, and they were very appreciative of the fact that they were able to participate in this thing, and so it was very moving for me.
That's cool. I mean, you feel like one sentence war story.
We had robots deployed in hotels. There's lots of opportunity for things to go wrong. I think one particular example that's particularly interesting is because of poor Wi-Fi and because of unpredictability of guests, the robot sometimes gets lost. And we had an example where a guest had a bag that he needed to get out of the elevator and push the robot out of the elevator on a random floor.
Oh.
The hotel's like 30 stories, and all the floors look identical. So the robot has a camera, but you can't tell what floor it's on because everything looks the same. And the hotel calls us up and says, "Where's the robot? Can you find the robot for us?" They're in another state, right? They didn't want to send an employee to every single of the floors and look around for the robot. And we had quite a chore trying to figure out where the robot actually was.
So it sounds like the engineering adage, which I like to use, anything that can go wrong will, unless you make a deliberate effort to make sure it doesn't. All right, well, I want to thank you for joining today, and thank you.
Yeah, thanks for having us.
All right, thank you. I think that's actually a really interesting note to lead on and to leave on, that anything that can go wrong will, right? It's and we need to prepare for that as we innovate and as we develop our next generation of solutions. And to that, so join me again in thanking Erin and the robotics panel. We're going to have to hold questions for now. We've got our next panel of experts coming up to talk about clean tech. These folks are going to be with us for the rest of the day, so look for them. After this next panel, we'll break for a lunch, and anybody with the full session pass can join us for lunch in the exhibit hall. So